Hi, I'm Craig Smith, and this is Eye on AI. Qualcomm Technologies is powering the shift to fifth-generation wireless communications known as 5G. In this sponsored episode, I speak to two of the company's product managers leading the company's efforts to use AI to enhance 5G, reduce on-device power consumption, and give developers the tools necessary to make devices smarter and faster. Ziad Ashgar leads planning for Qualcomm Snapdragon mobile platforms, which bring AI into smartphones, smart speakers, and self-driving cars, among other things. Xinyi Xu works with device manufacturers and software providers to help integrate Qualcomm Technologies solutions into their products. I hope you find the conversation as enlightening as I did. So, Ziad, why don't you start by introducing yourself, and then Xinyi, you can follow.
Hi, my name is Ziad Ashgar. I lead overall Snapdragon planning. Snapdragon is, of course, the Qualcomm line of products that we put into handsets or smartphones. I also look across the different product lines that we have at Qualcomm, and that includes, of course, automotive and mobile handsets and IoT and many other areas. And my team also looks at the Snapdragon technologies. So one of those, of course, key one that we're looking at nowadays, and we will be talking about today, is artificial intelligence. But I look across all the different technologies that go into Snapdragon products. I have a background in engineering, and I've spent some time in R&D. And it was really interesting because there are many analogs that you see between, let's say, the stuff that we looked at for modem technology sometimes or other aspects, and how AI has kind of changed over time from when we were in school. And it's really gotten to a point where things have gotten much more capable, and that's really kicking off this completely new age of AI. But I started with working on wireless technology, and since then I've actually changed over more towards application processor. I have been associated with the smartphone technology from the get-go, and I remember the first products that I worked on was a Palm Pre, if people remember many years ago. Maybe I'm dating myself. That was, you can argue, a real high-level OS device. That's kind of where this whole revolution started towards smartphones. And honestly, it's every transition that we have seen on the air interface side has been exactly mirrored with a huge increase on the application processor technology side as well, which is Snapdragon. So that's kind of what we do now.
And Xinyi, what about yourself?
So my name is Xinyi Xu. I started my career at Qualcomm as a custom engineer. So I work with our customers a lot to help them to implement our technologies into their smartphone products. And later on, I joined Zia's AI product management team. My job here is to work with our customers and help them enable their AI use cases on the Snapdragon devices. So when I say our customers, they can be the phone manufacturers, we call them OEMs, and they're building, say, the camera filters or voice systems, all the very common AI use cases nowadays. And our customers can also be independent software providers. They create AI models and they provide the models to our OEMs to use for their product. So a lot of features that you see on the camera apps are actually provided by the independent software providers, for example, portrait mode or low light photography. And of course, we also need to take care of all the app developers out there like Snapchat or Google Lens. And those apps are very good examples of all the AI use cases on device. Like you could simply just open the camera and use Google Lens to quickly identify what the breed it is for a dog. Or you can point your camera to a label with Wi-Fi network name and password, and it will automatically connect your devices to the Wi-Fi network. So the bottom line is we want to make sure that our customers can take advantage of our Snapdragon devices and all the AI engines that we provide. It's very important for us to provide the tools for our customers so that they can access our AI engines very easily and they can speed up their models very easily. And after providing all the tools, I wish I can say that my job is done. But no, there are so much more of the software behind the scene. From top to bottom, there are multiple layers of software stacks that we need to enable so that we can make sure all these AI models can run very smoothly.
For a lot of listeners, and for myself, I think of Qualcomm as a semiconductor company, or at least providing semiconductor design and software. I had not thought of Qualcomm as an AI company. When did Qualcomm start developing AI products, and is it developing those products to enable new semiconductor products or expand features of semiconductor products? Do they go hand in hand, or are there AI products that are separate from the semiconductor products on which they run?
The answer is yes, Craig. It's all of the above, really. I'll give you a little bit of a perspective on how we started doing this. So we have a corporate R&D division in our company, and that division has been working on AI research for more than a decade today. We had our first AI-capable product announced in 2015. And since then, we have continued to expand on the Snapdragon roadmap. So we are on the 5th generation AI engine, and we can talk more into the details of that next. But we haven't really just stopped there. We have taken AI capabilities into other product lines as well. So we have what we call our Vision product line that is AI enabled, and that we launched a couple of years ago. And once we have had this root IP developed, we've taken that into the automotive line and also into audio and other IoT-like lines. But that's talking about how we have gotten to where we are at. But to your other point, we don't look at AI just as a feature that enables our products. AI is working on our products and our processes in many ways. Like some of the examples that Shinny was talking about as to how AI is used to enhance pretty much every use case that you can imagine. So we already have pretty well established imaging use cases dramatically enhanced, dramatically changed by the application of AI. Some of the things that people are very used to, like night shot and the ability of the camera on the phone to be able to see in pretty dark room and still be able to make sense of what was in that room, is one of the early applications of AI. We see that continuing to develop in terms of more and more use cases. That is a use case at the device level. But then the way we are looking at AI, Craig, is also something that is enhancing in each and every block within our chips or our products that go into these product lines. So for example, we are applying AI to our modem technology. This is the technology that allows the handset, for example, to talk to a base station. And we use it to have even better reception in most challenging of channel conditions, for example. So that's an example of how we're applying AI inside our products. And then at a more fundamental level, we are even applying AI to the way we design our silicon and our chips. So it's really at all of those levels.
Are you supplying models that reside on device or on chip?
So far, the way that the edge products are working is you will, of course, have the model that's trained somewhere off in the cloud, because that's a very, very intensive task. And once that model has been trained, you, of course, have it running on the device. But now, for even a single use case, you might have multiple different neural net models running. For example, on the audio side, there might be a network that's enhancing audio. There is one that might be doing automatic speech recognition. So there is multiple one of them. But there are aspects where we are doing things like federated learning, for example, starting to do that on the device. So yeah, absolutely. Mostly inference, but in time, we think it starts to become more.
That's fascinating. Can you describe Snapdragon again? I mean, is that a class of products? Is it everything that's related to AI? Is it 5G specific?
So Snapdragon is our line of products that go into a handset. And what it encompasses is basically two main sections, which is the modem technology, which would be your air interface like 3G, 4G, 5G, and then the application processor part. Now, these two technologies could be together in a single product, or they could be separate, but usually we have them all integrated into one piece of silicon. And in the application processor side, you would have the camera, the CPU, the graphics core, the AI, and all the other pieces that are pretty much the brains of the device. And then what we do, Craig, is we take some of these Snapdragon technologies beyond handset, like an automotive cockpit-like scenario. Why? Because there is a large display in the car. You actually have multiple displays in the car. You have the need to be able to make sense of the audio. You want to be able to render pixels onto those different displays. You want to be able to make sense of what the driver is doing. You want to be able to make sense of offering entertainment and connectivity. And all of those things are extensions from a Snapdragon product on the handset as it goes into these adjacent areas.
Can you explain why AI is important for 5G or 5G is important for AI, and particularly at the edge, because you need to have the edge devices communicating seamlessly with back-end technology. Is that right?
Yes. 5G makes AI better and AI makes 5G better. We are going to continue to add more and more intelligence to the device at the edge. And as we do that, you give the device the ability to do a lot of the AI inferencing and processing on the device. Now, that requires very specific capabilities because remember, we are doing all of this AI in a product that fits in your hand, very small form factor, has a very small battery. So you got to do this processing at absolutely the lowest power possible. In the edge, what is really pertinent is the performance per unit power. How many inferences can you do for a given amount of power or joules of energy? That's what Qualcomm has been singularly focused on. But then you do all this processing on the device, and you want the user data to be processed and catered to on the device. So it does not need to be sent anywhere to be processed. So all the data that needs to be processed on the edge, we today have the ability to be able to process it on the edge. But let's say there is data, there are aspects that require more AI processing, for example. Then you have this amazing 5G link in the middle now that's reduced the latency that used to be there in prior technologies, such that now I look at this as literally the device and then the cloud edge and then the cloud all becoming like an extension of each other because of 5G. Because of that very high speed and the very low latency, now this becomes a case of a distributed intelligence that spreads all the way from the device into the edge cloud and then into the cloud. So that's how it makes AI cases better. But let's now turn it around. So if we're talking about 5G technology itself, where Qualcomm has been leading the pack in all the different flavors of 5G, like millimeter wave and sub 6 gigahertz and their variants, and each have their own challenges. The way AI can make 5G better, and what we are doing right now is, you can actually apply AI algorithms to make reception better. That phone has contextual information, for example. It knows whether you're walking or not. It knows your orientation. It knows your location. And then if you couple all this contextual information on top of what the modem inside has going on, you can actually make that reception and throughput and the whole link adaptation much better. And that's how AI makes 5G better. So we really look at these two as symbiotic technologies that work together very well.
And you're talking about being able to switch between bands, between millimeter and sub-6 seamlessly, either as you move or to conserve energy or something like that. Because there's been a lot of talk about millimeter being very powerful but not having range, sub-6 not having as much power but having the range. And then in the United States, there's the issue with the military occupation of the mid-band. I've read that Qualcomm is developing the ability to switch between bands depending on the location of the device or what bands are available.
Qualcomm is unique in this regard that we have the ability to go between millimeter wave and sub-6, which is an advanced feature. One use case that's very clear to me, Craig, is many times I'm walking out of my office. And as I walk out, sometimes my older device does not know when to drop the Wi-Fi and go to cellular. Very typical case that I'm sure many of us feel. You could actually apply AI to have pristine link quality depending on the application that you have running on the device. That's actually a very good AI problem. And now you can actually optimize it, and you should be able to know if that quality of that link is being maintained, whether that's via Bluetooth, whether that's via Wi-Fi, or whether that's through WLAN or WWAN, which is like the cellular technologies.
How extensive is the 5G network at this point in the United States, particularly for millimeter, because millimeter requires some infrastructure investment, if I'm not mistaken?
For millimeter wave, the advantages are many, actually. So number one is that you have large swaths of spectrum available at those high frequencies that are not being utilized by anybody. And as you know, the spectrum utilization at the lower levels, like sub-6 and below, it's quite congested. So for example, when we are running millimeter wave now, we can actually have 800 megahertz band. That's a huge band. That's really the promise of millimeter wave. Envision a stadium-like environment. You have so many people who require coverage, and millimeter wave is the ideal technology for that sort of a scenario, for example. There is a reverse problem as well, right, Craig? If you're running at low frequencies like 700 megahertz or something like that, you actually have too much interference. So we think millimeter wave actually works greatly. The main operators that we're working with have deployed millimeter wave, and they are deploying millimeter wave. And I'd say from a 5G perspective, pretty much every major premium tier OEM or handset vendor has millimeter wave capability on their device today.
And then in terms of the network, there'll be local millimeter band networks, and then for long distance connectivity, there'll be sub-6. Is that how it'll work? There'll be sort of a hybrid?
It can be a hybrid, but you also still have, of course, 4G fallback capability, but the density of deployment can actually make millimeter wave work very comfortably in urban areas, which is really the place where you need that very high throughput and very high capability. And then, of course, today, even driving down the interstate, once in a while, you see 3G come back even. So where it's needed, you will have 5G really shine. We, of course, create products for the handset market only. And handset typically has to lead because, see, when a user or a consumer is buying the device, he wants that handset to be able to work for a couple of years at least. So we are always ahead of the infrastructure side in many cases. But our strategy is really that we support both millimeter wave and sub-6 gigahertz because there are advantages for both. And we're far ahead of anybody else on millimeter wave technologies. We've actually enabled modules and other approaches that allow our customers and our OEM partners to be able to launch quite easily with millimeter wave.
Shini, I want to get you into the conversation on the power efficiency of AI. Can you give some examples of 5G use case in which the power efficiency is really important?
Yes. So from an antenna perspective, if you are connecting your phone with the base station and the base station will transmit it to another phone that you're trying to connect to, that means your signal is transmitting power. And on the other side, you're receiving power. So antenna is really important piece of the magic here. You want to make sure its radius as much as possible. And there are a lot of challenges since now phone is really small and antenna is built into our phones. A lot of times, based on how they touch their phones, how they use their phones, consumers are touching their antenna or even blocking their antenna. So we're looking to see how AI can learn how consumers use their phones, specifically for their phone only, because different people have different habits. And so we create an AI algorithm to understand when we can move to another antenna so it can transmit without any blocking, or there's other components in the phone itself to change your antenna patterns or antenna impedance. So you can use the least power to transmit the highest power to the other side. Maybe you're in the woods and the signal is bad. So your phone is trying to search for signal. It's transmitting really high power to connect to the other side. But if your antenna can actually transmit all the power from the battery to the power amplifier and throughout the antenna, that will help us to save battery life.
That's fascinating. Battery life is one of the most frustrating aspects of mobile devices for most people. And other than mobile phones or smartphones, you have been working a lot on autonomous vehicles and things like that. Can you talk a little bit about those use cases?
So basically, we have the ability to do AI processing and inferencing at the lowest power possible, right? So in automotive, I actually have an advantage that nobody else has because I can actually do that processing at the lowest power possible. But what makes AI in automotive much more interesting is typically you're looking at multiple cameras, you're looking at multiple LiDARs, multiple radars, sonars in some cases, and then you are trying to create a complete 3D view of what is around the car. And all of that is happening continuously because the car might be moving at 70, 75 miles per hour, or even above that, depending on who's driving. Being able to then make sense of that information in an environment where you have people's lives at stake makes it a very, very special sort of a use case. All the learnings that we've gotten from the handset side, we have applied to the automotive side, but we are doing much more than that because there's a lot more redundancy and other aspects that have to be built in to make automotive work. Close to our office, you can see the Qualcomm cars driving around because there is a lot of learning aspects to this too. If you look at the different levels of autonomy, there is level 1 to level 5. Level 1 might be a car tells you if you're going out of your lane, if you're coming too close to the car in front of you and it brakes for you. And level 5 is really when you have a full autonomous car that can actually drive on its own entirely. The AI processing capability from that level 1 to level 5 is vastly different. So what we are offering as a platform is what we call our Qualcomm Ride platform, is something that scales from maybe 20, 30 trillion operations per second for level 1 like performance, all the way to north of 700 trillion operations per second to get that level 5 like experience. So we are really covering that full gamut in automotive.
And reducing the power required to run these sensors or to process near these sensors. Does that allow then more sensors than would otherwise be supported by a platform and by an automobile or a smartphone or an IoT device?
Absolutely. So if you have an EV, an electric vehicle, and you are able to do a certain task with lesser power, your car can run longer with that same experience. And I think that's the real powerful thing. And the other very interesting thing about AI is it brings additional value. For us, as we're driving, we cannot see through a hailstorm or we cannot see through very hard rain, for example. But radars and sonars can. So those things will be running continuously at all points in time. And whoever can do it at the lowest power possible is the one that actually wins and is able to give the best experience.
Can you talk about some of the other research areas that Qualcomm's involved in?
Yeah, sure. So we have just open sourced what we call our AI model efficiency toolkit. So on this theme of being able to do more AI processing at the lowest power possible, our corporate R&D team has been able to take a given AI model and compress it. And we use different techniques to take out certain layers, for example, that are redundant. And that allows us to shrink the model down. And in some of the work that the team has done, the model actually reduces by a factor of 3. And that would give you like a third of the power because you don't need to do that much processing. Another aspect of that is quantization. So when the neural network model is trained in the cloud, it's trained at very high precision, 32-bit floating point in many cases. If you could reduce those number of bits to say 8 bits, which is a factor of 4, that would give you significantly more processing for the given amount of power. And what our team has shown is that for many of the algorithms, the accuracy that 8-bit provides is more than adequate. So that's one great example that the team has worked on. More recently, the team has actually mixed quantum physics into what we call our gauge covariant CNNs or convolutional neural networks. Let's say a neural network is trying to figure out if the object in an image is a person or a dog, for example. Once you rotate that image, it becomes very difficult for many neural models to be able to do that inferencing properly. But with these kind of gauge covariant neural networks, you're actually able to solve that problem. So that's another one, but there is a lot more that the team is working on, from being able to do better natural language processing, for example, to different architecture topologies to do even more AI processing at lower power.
Can you talk about some of the applications you see for federated learning and how you would integrate that into mobile devices?
So federated learning today is actually already being used on the device. For example, if you have ever used Google Keyboard, it actually uses federated learning on the device. And the way it does that is, of course, there is a model that's trained up in the cloud that's transferred to the device. But there are specific ways that you or I might use certain words or the way we type. And that learning, they use it to actually improve the model on the device then and there. But then it's generalized, and some of that information is sent back to the cloud to actually make that model even better. And additional information is sent by other users to continually make that model better in the future. And that's a really great example of customization for the user on the device, in this case, for having better typing and autocorrect-like function.
And so what's being communicated between the cloud and the device are just the weights that are being updated, and they're combined with weights from all the other phones that are connected?
Exactly. You don't need to share any of the personal information or the specific words, for example, that I might have used. You can just send out the weights and models and make that model much better for the next user who downloads Google Keyboard, for example. So it's really a group learning exercise which makes the experience continually better over time.
Are there other ways that you see federated learning being applied?
Yes, any use case where you want certain degree of customization. Another good example of this is actually the gallery in your camera app. It can actually figure out your family members, but that information or those faces stay on your device. So let's say if you search for your son, it's able to bring all the pictures of your son, but that picture of your son does not ever need to leave your handset.
Is Qualcomm doing anything in healthcare? I had a fascinating conversation with Fei Li, who's a prominent researcher at Stanford, about elder care and how there's a promise of having a network of sensors that can read the movement and infer the health of someone in the room. over time, particularly elderly patients who require monitoring. I'm just curious whether Qualcomm is doing anything in that area.
Actually, that's one of the very good applications of AI. We have a partner with whom we've worked in India to leverage the camera on the device. So again, the smartphone is really the ideal device for running AI because it has all of these sensors that very few other devices have. And by sensors, I mean it has multiple cameras, it has microphones, it has e-compass, gyro, it has proximity sensor, and you can actually use those to be able to create a lot of inferencing or a lot of AI-like scenarios. So in this particular case, in rural areas in India where some facilities might not be available, you could actually take a picture with some modification on the lens on the camera on the handset to be able to detect diabetic retinopathy, for example. And the algorithm would run entirely on the device. It would just take that picture, run the AI algorithm to ascertain if that condition was present in the person or not, and then alert a doctor or promote that as a possible scenario for an expert to assess and look at. But to your other question, you have a smartwatch, it has proximity to your body, it can learn a lot from there. You might have an XR glass in the future on your face, for example. You would have a smartphone in your pocket, and you also might have cameras in your home. You can actually start to make a lot of sense by combining the data from these. This ability to combine that information from multiple devices could be very powerful. So in our latest product, you can actually do AI processing at extremely low power, which means this processing is always on. For example, let's say it's 2 a.m. Our phones can now detect the sound of shattering glass. So there are certain security aspects, there are health aspects that the edge devices lend themselves very well to.
Are there any surprising use cases in the IoT world that Qualcomm has been involved in that listeners would be interested in hearing about?
I'll make one example, right? You probably have a security camera in your home. I have one, and it's one of the older ones, and it keeps alerting me for everything that passes in front of my home. Now, if that camera had certain degree of AI capabilities, it can, number one, ascertain, is this a car that's passing by or is this a person? And then number two, if it is a person, is it a person who's a part of my family? And then the third step could be by using face detection and face identification. It could say not only that that's a safe person, it can even perhaps give access to that person to my home as well. So you see how step by step that experience can totally change by application of AI. You can envision like a smart city like example. And at an intersection, you could have multiple cameras. And we have products like this on our portfolio now, like the Cloud AI 100, where you could have multiple video streams coming from that traffic intersection. And you can assess if there are two cars that have come very close to each other, for example, could that be an accident? If there is some degree of identification needed, you could then figure out the identity of those cars. The urgency or the seriousness of the accident can be ascertained. So there's a lot of applications on the IoT side that we are looking at today. Another big phenomenon is connected speakers. Everybody has them in their homes now, and as they're becoming smarter, you can just imagine that they really become that home hub. To your earlier example from Fei, that device can now be the one that integrates all the data from these multiple devices in your home and makes sense of it using AI.
Qualcomm is essentially a software company, right? Or a fabless semiconductor company. It doesn't build any hardware. It builds the software that runs on hardware or designs hardware that then is produced by other people. How does this work? So you work on a product, then do you have partners, maybe semiconductor fabs that take your designs or the software that you've created and integrate it into their product? Or is this hardware agnostic and it's available for device makers to integrate regardless of the chips that they have on their device? I'm just curious, the flow chart, how something from Qualcomm then ends up in a device that is made by Samsung or Apple or somebody else.
Sure. So basically, the flow works this way. We will develop the IPs or the hardware IPs. We'll develop the AI engine. We'll develop the camera block that goes into a semiconductor product. And then we will complete the full design of that semiconductor chip. So all the design, everything is purely done by Qualcomm. So we are a fabless solutions company. And then we transfer that design to a manufacturing fab. which could be a TSMC, could be a Samsung fab, or we work with multiple different fabs. And they would do that fabrication part of it. We work with SAT and other partners to have a packaged solution. Then it comes back to us for testing, ensuring quality. And in parallel, we have our software teams that are writing software for it. So from scratch, for each of those different IPs that I talked about, like the artificial intelligence engine inside the chip, the teams are working on writing the firmware, the software for it. We integrate that onto that hardware. We get it to commercial quality, ready to launch. And then we start to engage with our customer partners. And they would take that hardware and software, pretty much all of it designed entirely by Qualcomm, and create a handset where they would make the choice for, say, the particular specs of the handset or the cost or the capabilities that they're trying to target. And they would then perhaps add additional software on top of that, or a different solution for camera, display, and other things to be able to get to a handset that they believe gives a good experience to the consumer.
And is it largely pushing technology and solutions out, and then those are being chosen by partners for integration? Or are you designing to the requests of your partners? They want some feature on a camera, and then you take that requirement and design the software and the chip that will provide that feature. Is it a push or a pull?
It's actually multiple factors. So we will go out and do surveys for consumers. Because, something like a smartphone is a very personal device. Every consumer has pet peeves, or they might have areas that they really love, areas that they want to improve. So we'll go talk to consumers. We'll do multiple surveys in the year, multiple different geographies. Of course, we listen to our customer partners who might say that, hey, I want to have this specific feature because they want to enable a certain experience on it. And then we ourselves have a certain vision for innovation of the new capabilities that we're putting into our products, because we know that that's a distinction, or it enables a completely new experience that was not possible on the device in the past. So all of those experiences, we talk to our operator partners, we talk to all those different people in the ecosystem, and then based on that, we create an optimal product. And we, of course, do multiple different products in the year for different tiers of handsets, different tiers of IoT products, auto products, XR products, and so on and so forth.
Correct. You mentioned that people see us as a hardware company. As a consumer, we just want our phones to work. We don't really hear too much about what's going on behind the scene. But think about what happens when you open an app, when you're using your phone. How does it from the app level get to the hardware bottom level? If you pick any of the Android phones in the market, any of them, if you download any of the app from the App Store, your phone will just run the app on the CPU by default, and the app will run no matter what. But the CPU is much slower and consumes much more power. So you want your app to run on our AI engines that's designed for the AI workload instead of CPU. There are so many different ways to get you from the app to the AI engines that we provide. Let's say your app is point A and our AI engine is point B. We created different products that will plug in your point A app and take you to point B. But if you want to determine your own route and be adventurous, meaning you want to learn how to schedule or program on our AI engine, we also have those framework for you, but the learning curve might be a little bit higher. We provide the Qualcomm Neural Processing SDK to help our customers implement their AI algorithms onto our AI engines. And what it does is take an AI model from the developer, and the SDK will convert the models into a format that our Snapdragon can understand. Because the TensorFlow language is not something that our Snapdragon chipset can chew on. And after we created something that our chipsets can understand, our customers just need to download the converted format and load it into the device. And that's it. Their job is done. And we'll take it from there. After that, during runtime, we execute the models. And we break it down into small pieces into operators, and then we dynamically schedule them onto our engines for processing in the most efficient way. We have many engineers spending month after month to add more operators and to optimize them based on our AI engine architectures, so we can get you from point A to point B in the most efficient way. From time to time, we get requests from our customers asking us to support more operators for their AI models. And those operators, you can think of them like the buttons on your calculators. And we develop all the buttons that you commonly use, but provide a feature called the user-defined operations. So you can add new buttons to your calculator anytime you want.
And your market, your customers are device manufacturers primarily, whether it's a mobile device or an IoT device or a EV manufacturer. How broad is the customer base?
Yes, it's very, very broad. Like we have a partnership with iRobot. They use our AI engine so that they can run their computer vision specific AI use cases on our hardware. Imagine if you are iRobot and you are vacuuming a very big house. You don't want all of the computer vision processing to drain your battery rate. So engineers who use our software product because they're not familiar with the language that's on top of our AI engines. The software product itself actually helps them to get to the hardware that we have available.
From the consumer's point of view, this is all hidden. And I think most consumers, if they hear Qualcomm, they think of CDMA and cell phones. Would you prefer that people appreciate the role that Qualcomm plays in their devices?
There are many products publicly available, especially the tools that can convert the models into something that our chipsets can understand. The example that I just gave is the Qualcomm Neural Processing SDK. And this is the SDK that tons of developers out there are leveraging to get access to our hardware. And there are other products available in the market, like we partner with Google to enable their Android neural network API so that their TensorFlow Lite customers can get access to the GPU or DSP instead of just using the default CPU. Another product that we're working with Google on is the TensorFlow Lite. We call it a hexagon delegator. What it does is to get the users direct access to our hexagon accelerator. Hexagon is our DSP accelerator. If you are leveraging, for example, the NNAPI that Google provides, it will go through CPU first, and then CPU will schedule the workload and send it to GPU and DSP to process. From CPU to DSP, we're seeing 14 times faster acceleration. So that's why Google is partnering with us to enable our customers to get direct access to the DSP to bypass CPU once for all. So you speed up your model even more.
Can I ask a question about recruitment? I mean, a lot of my listeners are students at different levels or researchers. Do you have trouble recruiting talent given the shortage of AI engineers and PhDs for the kind of research that you're doing? And where do you generally recruit?
Yeah, there is a lot of need and people are much in demand, but we publish a lot of papers at CVPR and other conferences. So we are able to get good candidates, definitely. But there is always need for more. And I think if there are people who are looking at new areas, this is definitely a good one to consider for very good job prospects in the future, because I think the need for AI is going to continue to grow in multiple industries.
Is there anything I'm missing that you'd like to talk about, either on the research side or on the implementation side?
One thing I'd like to add is the research project that Ziad mentioned, the Qualcomm AI Model Efficiency Toolkit. It started with a research project, and that's how Qualcomm does things. We have research and we know how it can help our consumers better, and then we productize it. So this is a public available tool. It's open source, so it can benefit to all the developers out there. A lot of use cases that Ziad mentioned are all good use cases to leverage this tool. Because of privacy, you want everything to process on your device, and you want things to work with or without data connection. And you also want it to be very power efficient because it's running on the edge. So I think this AI model efficiency tool will help them get there. It ties back to your power question and it complements our power story. AI on the edge devices is doing most of the inferencing. It's not so much of a training. So when you're talking about training, it happens on the cloud. So you don't have much restraint. When inferencing happens, it's on the device, the equation is running and providing an answer to the problem. Like whether this picture has a dog or detecting if there's music playing in the background and if you want to identify this music. So the big difference between the training and the inferencing is the power efficiency because You don't want to see your battery drop after you're trying to, identify a duck picture. Another important thing on the device is the model size. You will want to minimize the model size because the memory space is limited and also the bandwidth you have on device is limited. So that's how AI model efficiency tool help you to quantize, help you to compress, help you to reduce the size. And at the end of the day, it really helps you to make your AI model possible on the device because you don't want to sacrifice your battery life with all the cool things that you want to do.
I was just going to comment a little bit more as to what new use cases we have coming up and what we are kind of excited about. The way we have applied AI to the handset side of things started with imaging. We're able to do all these amazing experiences like bokeh effect, completely done on this very small device like a handset today. We also had a lot of AI application on audio and for echo and noise cancellation, things of that sort. So you can imagine we have done a lot on imaging and audio, and this will continue to happen. But in the next step, those same learnings, those same neural networks that we applied to a single image are going to get applied to video. So you'll have all those experiences in video. And we are looking at pretty cool use cases where you can literally remove an object or add an object. And then the extension of that would be gaming, which is a huge phenomenon today in the world. You can now interact or play a game through VR glasses. And as you're playing through those glasses, there is a multitude of AI capabilities that you need because you interact with that virtual world with your hands. You need to be able to detect the exact position of your hand. You could envision talking to a character in the game using natural language rather than pointing a joystick at them. So all of those things are coming from the learnings that we have on AI, and they're all set up to be solved using AI techniques. And then similarly, we can now do translations on the device. You could literally be speaking one language into the device, and the person on the other end will hear a completely different language. There's multiple different techniques that have to be used to get to that experience. You, of course, have to do speech recognition. Then you got to do a transformer network that actually changes that speech into a different language. And then you take the text that's translated, converting that to speech. So that's the text-to-speech part of it. And what we're trying to do now is that speech generated in a different language from what you spoke, we can now apply what we call audio style transfer on top of that. So that that speech sounds like I would say those words in that other language. Things like this are very, very powerful, and I think can really bring down the barriers in the world. You pick up a phone, talk to anybody else in the world, and you don't even know if that person speaks your language or not. That sort of AI technology is horizontal across all of our products and is really transformative in many of the experiences that are coming up.
That's it for this week's podcast. I want to thank Ziad and Xinyi for their time. If you want to know more about Qualcomm Technologies' work in AI, visit qualcomm.com. You can find a transcript of this show on our website, EyeOnAI, that's EYE-ON.AI. We love to hear from listeners, so get in touch if you have comments or suggestions. And remember, the singularity may not be near, but AI is about to change your world, so pay attention.